Hello everyone, this is D. Chiranjeevi, Assistant Professor, Department of Information Technology, Aditya University. Today I am going to discuss operators and types of operators. In this lecture, students will be able to discuss the operators and types of operators. So the outline of this lecture is various types of operators like arithmetic operator, relational operator, logical operators, bitwise operators, assignment operator, ternary or conditional operators, unary operator, special operators. So arithmetic operators. To perform arithmetic operators, we need two operands. Okay. So the operators which are used in arithmetic operators is plus, minus, multiplication, division, and modulus. So the syntax is given here, how to perform a plus b, a minus b, a multiplication b, and a division b, a modulus b. The difference between a division and modulus is if you perform a by b, so quotient will be the result of division, remainder is the result of modulus operation. So in this example, we will try to understand how arithmetic operators work. So a program will execution start from main function, so then the control flow falls down, so then it is reading two values in scanf. So let us say a value here given 100 and b value given 200, so a value 100 and b value 200. So then you are performing addition, subtraction, multiplication, and then division and modulus. So here I will perform 100 division 200, so in this case you will get quotient is 0, so finally you will get 100. So if you see in this example, so addition, subtraction, multiplication you can easily understand, then so you see the quotient is 0, that's why the division result is 0. The same manner, and modulus result is, I said remainder, so remainder is 100, so modulus is result is 100. So for division we need to look after quotient, and for modulus we will look after remainder. Okay. So this program you read two values, then you performed the all operations in the printf statement itself. So it will print the statement, and then for the respective format specifier it will display the result value. Then relational operators. So by using these operators you can find the relation among two operands. So it is less than, and then greater than, less than or equal to, greater than or equal to, and then not equal to. So these are the relational operators. So here you will check less than, let's say a value you have taken 10 and b value you have taken 5. So now if you are using relational operator, if it is true, if the condition is true when you are checking a relation, then you will get the output is 1. If the condition is false, your output is 0. So 10 less than 5, so a less than b, so a is 10, so b is 5, so 10 less than 5, this is false. If it is false, you will get result as a less than b, that is 0, your result is 0. The same manner a greater than b, so 10 greater than 5, that is true, in this case result is 1. Then less than or equal to, in less than or equal to it will compare left operand, that is less than, and then less than or equal to less than b, and then it is check left operand equal to b. So here 10 less than 5, then or logic normal or, then it will check 10 equal to 5. Two operations. So 10 less than 5 is also false, 10 equal to 5 is also, so overall 0 0, or final result you will get 0. Okay. So a less than or equal to b also you will get 0. Then a greater than or equal to b, so a value I have taken 10, b value I have taken 5, so a greater than or equal to b. So here first of all it will check, so 10 greater than or equal to 5, or then it will check 10 equal to 5. In this case this condition is true, you will get 1, and this case 10 equal to 5, it is false, so it is gives. In odd truth table, if you see one case also true, then the final result is 1. All the bits are false, then only it is false. So this result is 1. Then equal to, so 10 equal to 5, so ultimately this is not equal, so you will get false, so that's why you will get 0. Then A not equal to B, so A is 10 and B is 5, so 10 not equal to 5, that is true, so in this case your result is 1. Let's understand this relational operators with an example. So you have given A value 100 and then B value you have given 200. Now A less than B, 100 less than or equal, 100 less than 200, so true. So in this case that's why 1, and A less than or equal to B, so 100 less than 200 or 100 equal to 200. So this case is true, this case is false, so overall result 1 0, you will get 1. So that is why A less than or equal to B 1. Then A greater than B, so 100 greater than 200 false, so you are getting 0. Then A greater than or equal to B, in this case 100 greater than 200 or 100 equal to 200, so this is also false, this is also false, so overall result you will get false. So A greater than or equal to B is 0. Then A equal to B, so 100 equal to 200, no, so that's why A equal to B value is 0. A not equal to B, 100 not equal to 200, that's why it is true, so in this case you will get 1. Logical operators, so these logical operators were used to check logical relation between multiple conditions. So this is logical and this is logical OR and this is logical NOT. Okay. So now let's understand these logical operators with the help of an example. So here I have taken various variables like A, B, C, D. Then I have read their values by using scanf. Then I am checking condition like A less than B, A greater than C. So I am performing logical AND operation between them. So A less than B. So if you see A value 100, I am taking, B value I am taking 200, and then C value I am taking 250 and D value I am taking 300. Now if you see A less than B, 100 less than B, so that is true. So 100 less than 200, so this is true, so you will get 1. So logical AND operation, and then A greater than C, so 100 greater than 250, so this is false, so you will get 0. In AND truth table all the bits needs to be true, but in this case this 100 greater than 250 is false, so final result is 0, so that's why you are getting 0. Then logical OR operator, so A less than B, that is true, 100 less than, so now this time I will perform same condition, I will perform OR logical OR. So this bit you will get 1, 100 less than 200, that is 1, and then OR, then A greater than C. So A greater than C, A is 100 greater than 250, so that this is false, so in this case you will get 0. So this was 1, this is 0, but in OR truth table all bits are false, then only it is false. So but this is OR, so if one bit is also true, then you will get final result as true, so that is why 1. So here the output is 1. Then NOT, logical NOT, so actually logical NOT will change the result. If A equal to B, let's say it is true, in that case NOT, if you apply NOT, it will make it false. If it is false, if you apply NOT, it will make it true. So 100 equal to 200, so this is false, but if you are applying NOT, so true, if you apply NOT, it will make false, so ultimate result we will get is false. So A equal to B, this is false, so false if you are applying NOT, so that's why it is true. So A equal to B, you will get output is 0 because the condition is false, but if you are applying 0 NOT, so ultimately it will give you 1. Okay, so 0 means false. If false, apply NOT in front of it, then it will become true. Then bitwise operator, so these are the bitwise AND operator, bitwise OR operator, bitwise XOR operator, then bitwise complement operator, bitwise left shift, bitwise right shift. So we will understand these bitwise operators by using examples. So to understand bitwise operators, we must understand 2-bit, 3-bit, 4-bit, decimal to binary conversions, then only we can understand. So I have taken these values 5 and 3 and I have taken the respective binary values of 3-bit. Okay, so these 101 and 011 are 3-bit binary numbers. Okay, 3-bit binary numbers respective of decimal numbers of 5 and 3. Okay, so here 5 means the value is 101 and 3 means the value is 011. Okay, if you perform AND A and B, so that means 5 and 3. Okay, it will check. So AND truth table, you know, so both bits are true, then it will become true, otherwise it is false. So 01 you will false, 10 also false. Okay, so the 001 is equivalent to 1 in equivalent. This is the binary result and it will convert it to decimal number, decimal. So the decimal result is equivalent to 1, that is why A and B value is 1. The same manner, if you are performing A or B, so A or B, that is 5 or 3, so in OR truth table all the bits are false, then only false. So 11 you will get 1, 01 you will get 1 and 10 also you will get 1. So this 111 is equivalent to 7, so that's why your result is 7. Okay, the same manner A XOR B, so A XOR B you can write like this. XOR truth table says if both the bits are true then also false, both the bits are false then also false. So now if you see both the bits are true, that's why it is false. So rest all the cases true. So 10 01 true, 10 also true. So 110 is equivalent to 6. So that's why A XOR B is 6. Then bitwise complement operator. So complement you can find simply minus of A plus 1 formula. So let's say A value I have taken here, it is 5. So simply you can write complement of A, you can find minus of A plus 1. So minus A plus 1, A value 5 plus 1. So here you will get minus 6. Then A right shift B value. So A value I have taken 5, B value I have taken 3. Okay, if you are performing A right shift means right shift division with 2. Okay, so with 2, how many times? B times. So 5 by 2 first time you will get 2, 2 by 2 second time, so you will get 1, 1 by 2 you get 0. So the result is 0, that is the reason A right shift B is 0. If it is left shift A left shift B, left shift means multiplication, multiply with 2 B times. So A value 5, B value here 3. So 5 into 2 first time, into 2 second time, into 2 third time. So the overall result is A left shift B. So 5 into 2 10, into 2 20, into 2 40. So the result is 40. Okay, so actually this bitwise operator will perform operation bitwise, but if you perform bitwise, this complement, left shift, right shift will take lot of amount of time. So by using these formulas you can apply. So for binary complement you can use minus of A plus 1, that is the formula. For left shift you can multiply with 2, how many times? B times. For right shift you perform division with 2, how many times? B times. Then assignment operators. So this is simple assignment operator. This is plus assignment, minus assignment, multiplication assignment, division assignment, modulus, and assignment, or assignment, XOR assignment, right shift assignment, and then this is left shift assignment. So by this example you can understand this assignment operators. So here I have taken a value and b value. So a value I have taken 100 and b value I have taken 2. So here if you write a plus equal to b, this is a assignment plus operator. So it means you can write a equal to a plus b. After performing a plus b, that a plus b value again assigned to a. So a value 100, b value 2, a is a variable here. So initially a value 100. Now after performing plus, again you are assigning the value to a. So a value 100 plus b value 2. So again a is storing. So 100 2. Now if you print a value, it will give you 1 or 2. So here a plus b performed and again stored in a. So here a value is 1 or 2. That is the reason. Okay. Then a minus b. So now updated a value is 102 and then your minus b. So a equal to a minus b, right? So you can write like this: a minus equal to b. It gives a equal to a minus b. 1 or 2 minus 2. So you will get 100. Okay, that's why it is 100. So updated value I am using here in this program. So a into b. So right now a value is 100 and b value is 2. So a into equal to b. So a equal to a into b. So a value is 100, b value is 2. So you will get 200. And now right now a value, updated a value is 200. Okay. So now a by b. So a by equal to b, it means a equal to a by b. So a value it will take 200 and by b value it will take 2. So again a value will be updated 200 to 100. Okay. Now you are checking a modulus. So a modulus b. So a value is 100 and if you are performing a modulus 2, so your remainder is 0. So modulus operator will. Then a left shift b. So now right now when you performed a modulus, updated a value you got 0. So now left shift means multiply with 2. A left shift b means multiplication with 2, how many times? B times. So a value 0, you multiply any times you will get final result 0. And a right shift b. So by here again a value 0, so any times you perform division with 2, again you will get 0. Then ternary operator. So this ternary operator is also known as conditional operator. In this we will be having 3 expressions. So the first expression is a condition. If that condition is true, control will be go to expression 2. If condition is false, control will be go to expression 3. So now with this example you can understand. So here I taken a value 10. Now I am performing a modulus operation, a mod 2 equal to 0. So a value 10, so 10 mod 2 equal to this result is 0. So 0 equal to 0, this is true. If this is true, control will go to expression 2. So expression 2 is this one. So it will print a value, that is percentile d value. So that is 10 is even. So output is 10 is even. So unary operators. So plus is a unary operator and minus is a unary operator. Increment operator, plus is a unary operator, or you can say increment operator, and minus is a decrement operator. So this increment operator you can write, it can be pre-increment or pre-increment you can do, or post-increment also you can do, post-increment. Same manner, pre-decrement or post-decrement you can perform. So with an example you can understand very clearly. So here I'm reading a value in this program. So a value is let's say 100. So plus a means you will get 100 only, and minus a means you will get minus 100, and plus a, this is pre-increment. So plus means it will add plus 1. Generally these unary operators are performed on a single operand. Okay. So plus a, so plus means it will add plus 1 to the a value. So a value 100, so plus earlier, so plus 1 plus 100, so 1 at 1, and then a plus, in this case already a value here you got 1 at 1. Now here it will print only a value, so that is 1 at 1 only. After that a value will be updated in the next operation. Okay, in the next line if you print a value again, then plus will be, plus 1 will be performed, then here it will print 102. Okay, so here it is printed a value only, that's why it is 101. Then a minus minus, so it will decrement by 1 to the a value. So a value right now 102, so minus minus first, so minus 1, so here it will get 101. The same manner a minus minus, so first it will print a value only, so a value here 101, so output is 101. Then it will next line, if you try to print the a value, then minus minus is also happen, so 101 minus 1, so a value 100, so you will get. Then special operators, so comma is a special operator. To separate variables you can use comma operator. Then size of operator is there, so by using the size of operator you can find out the size of data type or a variable name or any value also you can give, so it will give you the size of variables, data type or values. And then type operator, this type operator will be used for typecasting purpose. When you convert one data type into another data type, then typecasting operator will be used. Then these are the special operators. So like a value I have taken 10, so by using the size of operator you can pass a parameter either data type or variable name or value. So here I have passed the variable name, so the size operator it will give, so based on the data type, so the number variable is of type integer, so size is 4 bytes. The same manner I have passed the value, so value is of a type integer, that's why it is 4 bytes. And then I pass a data type, so data type is also integer, so it will occupy 4 bytes. Next, float. Then this is typecasting operator, so actually number is of type integer, so what I did, so I used a typecast operator here, so that is float. So now your value it will print in float, so 10.60. So the summary of this lecture is, I have discussed various operators like arithmetic operators, relational operators, logical operator, bitwise operator, assignment operator, ternary operator, unary operator, special operators. Thank you.